Hi everybody. Today we're going to look at some exponent rules, and then we're going to work with some fractions as our exponents. So we're going to start with just sort of basic review of the things that we've been doing, because remember, logarithms are exponents, so they do follow the same rules. So of course, when you multiply, you add the powers together. When you have a power to a power, like here, you multiply them together. When you divide, like this one, you're going to subtract your powers, like this. So those are some rules. We cannot have a negative exponent. It's considered not simplified, so make sure that we get rid of those by putting that in the denominator. If it's negative and in the denominator, then that'll go to the numerator. It'll make more sense once we start going here. So the power on the outside of any parentheses, which is like this rule right here and this rule right here, right? So if you're multiplying or if you're dividing, it doesn't matter. That power has to go with everything. So the first thing I'm going to do is I'm going to take this power and I'm going to put it with each piece, the 3, the x, the y, the z. If there's already a power there, then we have to multiply those two numbers together. So now for x, it's already a power of 2, and 2 times negative 2 is negative 4. Y is going to have the power of negative 2, and z is going to have negative 4 times 2, which is an 8. Now, anything with a negative exponent has to get shoved to the bottom. Well, this is really 3 squared, so I'm going to call that 9, but that's going to go to the bottom. X to the 4th, because we moved it, becomes a positive power, and y squared, because we moved that, becomes a positive power, and we don't move the z. So the z stays the way it is because it's already positive, so it stays on the top. And as long as you don't have any letters repeated, like we don't have the letter x twice, we don't have the letter, and all of our numbers are simplified, it's finished. Now you got to be careful with the order. Before we actually multiply this, you have to take care of the exponents, right? Please excuse my dear Aunt Sally. So before we can multiply, we have to take care of the exponents. So in this first grouping, we'll call that, there's no power out there, so it's going to stay the way it is. So these guys are all good. Now with this one, we have to do 2 squared x, same thing as we just did, negative 4 times 2, so that's a negative 8. Y is going to get the power of 2, and z gets the power of 2. So before we start moving things around top to bottom, let's make sure we have all the x's together, all the y's together. It's a little bit easier to move it once rather than move it twice. So 2 squared is 4. Now we have x to the 3rd and x to the negative 8. We are multiplying, so when you add those, we get x to the negative 5th. For the y's, we have a negative 4 and a 2. So negative 4 plus 2, the power is now a negative 2. And for the z's, we have a 5 and a 2. So when we add that up, we get z to the 7th. And now the only thing we have left to do is take care of the negative exponents. So we're going to have a fraction. 4 is good. It can stay on top. Oh, this is a negative power right here. So this thing has to go to the bottom. So this will be x to the 5th on the bottom. Same thing with y. Y has a negative power. That's going to the bottom. But z is good. So z is going to stay on the top. Now for division, we're just going to subtract a power. So a goes with a. Be careful with your signs. This is 4 minus negative 3. So that is a to the 7th. For the b's, I'm just going to write this down. B is 1 minus negative 3. So that's going to turn into b to the 4th. And for the c's, we have 6 minus 4, which is just a plain old 2. Now, if we have any negative exponents, we move them. But if you notice, we don't. We don't have any negative exponents. So we're good. That's it. Now let's talk about fractional exponents. So when you have a fraction as a power, it changes quite a bit. So whatever your number is, let's say it's a, your fraction is going to be power over root. And by root, we mean square root, third root, fourth root, things like that. So we're looking at radical signs. So I'm going to come all the way over here. And so this is your first power. A is to the first power. and then it's to the nth root. So that little number goes in that power. That's called an index. And so here you can see the words, right? So the nth root of a raised to the mth power. So it goes power a to the mth, that's your power, and then the root is the denominator of that fraction. So all this says is to rewrite in radical form, which means we need a physical radical sign. So it's x to the first power, which you don't have to write that, I just put that there, which is the fourth, and it's also the fourth root. That doesn't simplify, so we're good. 32x, this is all grouped together. It's to the first power, and it's the second root. Now, you know when you have the square root, you don't have to put the 2 there. You can if you want to, but no number is automatically going to be the square root. Well, 32 breaks down, right, with your square roots. So the largest perfect square that goes into it is 16. We know the square root of 16 is 4, so that comes out. We do not know the square root of 2 or the square root of x. And so that's what we mean by simplify it. So again, here we have a times b. I mean, we just talked about how it's the square root. I got a little ahead of myself, so I'm just going to write ab. They're both to the first power, so if you want to have that, you can. But then it's the second root of the entire thing. And of course, with number 7, this is a plain 7, but it's 12x. They're both to the first power, second root. So 12 is really 4 times 3. And of course, that x is there. Now we know the square root of 4. There's a 7 there already. The square root of 4 is 2. And then we have 3 and x underneath the radical sign because we don't know the square roots of those. So this works out to be 14 times the square root of 3x. This is multiplying out here. Anything you bring out, you multiply. Anything you leave in, you multiply. So let's talk about other roots. The square root is the square root because it needs 2 of the same thing to come out. The cube root means we need 3 of that same thing to come out. So 8 is 2 times 2 times 2. So we have 3 2's. That means 1 can come out. The fourth root means you need to have 4 things to come out. And of course, we don't have 4 x's and we don't have 4 y's. So to simplify that, it is just what you see there. So for the square root, 11 squared is really 11 times 11. So what the square root means is you have to have 2 in order to bring 1 out. So we do have 2. The 3 is already out there. We bring out the 11. Anything we bring out of the radical sign gets multiplied together. 32. I'm going to break down 32. It's 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. So 1, 2, 3, 4, 5. So 32 is 1, 2, 3, 4, 5. Well, the fifth root means we need 5 of one thing in order to bring 1 out. So I have 5 2's, which means 1, 2 comes out. There is not enough x's, so that's going to stay home. Now, this is a weird one. I'm going to break this one down a little bit. I'm going to focus on the 5. 5 is really 4 plus 1. I need the 4 because I see a 4 there. So if we think about what this is the fourth root of negative 2a. And we can break this down into 4 of them times 1 more of these guys. It's still the fourth root, but there's only 1 in this set of parentheses, and there's 4 in this set of parentheses. I did that because we know the power and the root cancel each other out. And so when that's gone, the radical sign is gone, and the only thing that's left is underneath here. So this is negative 2a, and then the fourth root of a negative 2a. Now that one was kind of weird and maybe extra hard to simplify, but that's kind of another way you can think through. Now we've done some of this before, but we've not done it with fractional exponents. All right, so this is how it's going to work. When we have fractions, let's read the directions. So if we have radicals, we want it in exponent form. So that means take your radicals. Radicals are difficult, but fractions are a little bit better because your calculator can do fractions. Then we're going to use the exponent rules, which means if you're multiplying, adding, divide, subtract, and then the last thing is to rewrite it as a radical. But you got to make sure it's in simplest form. So that's the trick. We got to simplify these radicals. So we have x here, so we're going to add 1/3 plus 4/3. Well, that's got a common denominator already, so that's 5/3. That's the power. So we basically have x to the 5/3. Okay, let's rewrite that. So we have x to the 5th power, 3rd root. Well, what that means is we need 3 of one thing in order to bring one out. So what we have right now is this. All right, we have 5 x's. So it takes 3 to bring one out, and then these guys have to stay there because there's just not enough. So we bring one out, and then we have the cube root of x squared. Now, if you look at these two powers, 3 plus 2 is 5. So we can do some subtracting. You don't have to write it all out, but I'm just trying to give you as many illustrations as possible to show you how this works. So for number 14, we have to add up 1/4 plus 3/2. You can put that in your calculator. Make your calculator give you back a fraction. This is 7/4. We do not want a decimal. We need a fraction. And so we have basically x to the 7/4. Well, when the top number is bigger than the bottom number, that means you're going to have some simplifying to do. You can subtract those if you want, right? 7 minus 4 equals 3, which means if we bring out 4, that's 1 on the outside, and this is the number that's on the inside. But I'll write it out differently. So this is x to the 7th power, 4th root. X to the 7th power, 4th root. So there's 7 of these guys underneath there. So, right, if you think about that, 1, 2, 3, 4. So we need 4 of them. 4 of them takes 1 out. So now we have 1 out, and these 3 are left underneath there. Well, underneath is the 4th root. So you don't change the index. You don't change that number in the radical sign. That's still the 4th. And then again, you can see 3 plus 4 equals 7. That's why sometimes subtracting is a little bit easier. Now here we have a dividing problem with number 15. So dividing is subtracting. So again, that's why we like fractional exponents better, because your calculator does these a little bit better. So we have 5/2 minus 7/4. Put that in the calculator. Calculator gives you a decimal. It's 3/4. Even if it's 0.75, you need it to be 3/4. So this is essentially x to the 3/4. Well, the directions say we have to write this as a radical in simplified form. Oh, here the power on the top is lower, so we don't have to do any simplifying. So this is x to the 3rd power, 4th root. And there's not enough x's underneath there to bring any out, so you're done. This is a power raised to another power. This is multiplying. So we're going to have 1/3 times 5/2. Multiply straight across the top, straight across the bottom. Now remember, that's your power. So essentially we have x to the 5/6 power. Again, when the top number's small, we like that. So this is x to the 5th power, but the 6th root. We don't really care what the root is. You're going to, if it's a 3 or 6, you just have to still write it in there. So that's not a big deal. That's the 6th root. Here we have a power to a power again. So we're going to multiply 1/2 times 1/2, which is 1/4. So now we don't have a letter, we have a number, 32 to the 1/4. Well, numbers are harder because you got to think about all the numbers inside there. So 32 is, I think we just did this on the other side, but let's break it down again. 16 times 2, 2 times 8, 2 times 4, 2 times 2. So 1, 2, 3, 4, 5. So 32 is 2 to the 5th. Essentially. So we have the first power, but the 4th root. But 32 is this many, right? It's 5 of them. So the rule is it would need 4 to bring 1 out. Okay, so 4 of them, that brings 1 out, and we have 1 left. And that's how you simplify the numbers. This is why we like the letters better. Obviously, algebra, but you have to deal with some numbers sometimes. So this power is going to go with everything inside there. So that's 8 to the 2/3. And you're more than welcome to type that into the calculator just to see. If you get a decimal, you have to do it by hand. If you get a whole number, you're good. And then we have 2/1 times 2/3. So this is 4/3. So x has a different power. I'm going to treat these like 2 little separate things and see if I can put them together at the end. So if we take care of the 8, This is the cube root of 8 squared. And then this is cube root of x to the 4th. Well, 8 squared is 64. The cube root of 64. So 64 we know is 8 times 8. And 8 is 4 times 2. So we have 1, 2, 3, 4, 5, 6. So we have 6 of these things. And we have the cube root. So 3 brings 1 out. Oh, so we're going to bring out 1. 3 more brings out. So we have all of them on the outside. But here, we don't have enough. Oh, yeah, we do. 1, 2, 3, 4. And we need just 3 to bring 1 out. So 1's coming out, and then this one stays home. Now remember, it's multiplication. So 3 times 3 is 9, x. And then this is the cube root of x. The cube root stays. It's been the cube root the whole time, and it stays. Now don't let this mess you up with all these numbers. A negative exponent is a reciprocal. So this is the same thing as if we flip this over, you flip over the fraction, and you make the power positive. All right, because a negative exponent means this has to go to the bottom and 7 has to go to the top. So there it is. So let's take a look at what we have. We have power over root. So we have the 4th root of 7 over the 4th root of 112. Well, 7, there's nothing inside that, so we're good there. But let's look at this 112. That's 2 times 56, which is 8 times 7. And 8 is 4 times 2, which is 2 times 2. So we have 1, 2, 3, 4. So we have the 4th root of 7 over the 4th root of 2 to the 4th times, look at that, 7. So 2 to the 4th, cancel with the 4th root. So we have the 4th root of 7 over, that 2 comes out, the 4th root of 7. All right, because this is still underneath there, and this is still the 4th root. Well, look, these match. So the answer to this is just 1/2. Oh, but we brought out a 2. Yep. Didn't see that coming. Now you got to be careful. Don't just multiply these together, right? We want fractional exponents. You got to have these fractional exponents here. So this is x to the 1/3. We do things in fractional exponents times x to the power over root 1/2. Now you do 1/3 plus 1/2. You cannot add these because the little number in there does not match. And 1/3 plus 1/2 is 5 over 6. So now we have x to the 5 over 6. So remember, if the top number is smaller, you're not going to have any simplifying to do. So this is the 5th power, but the 6th root, which means there's not enough x's to bring 1 out. And so this is finished. So the trick sometimes is to switch your powers to fractions. You might not like the fractions, but the calculator will do that part for you. So take advantage of that. The calculator doesn't do the radicals. So we have x power over root times x power over root. So now we have to do 3/4 plus 1/2. Well, this is 5/4. Top number's bigger. So think about that. This is 1 and 1/4, which means we bring 1 out and we have this left. I don't know if that helps. So we have x to the 5th, the 4th root. So we have 5 of these. 4 of them means 1 comes out. And then we have the 4th root of this guy left. And that's how it works.